In this video, we'll discuss one more classification based on the interactions between the dispersion phase and dispersion medium. Is actually based upon the present interactions which are present between what dispersion phase dispersion medium. So whatever the interactions are there between dispersion phase and dispersion medium, based on that type of interactions, we can classify colloids into lyophilic colloid and lyophobic colloids. Let me discuss each and everything. The first one, lyophilic colloid is based on the interaction between the dispersion phase and the dispersion medium. Now, we got first one, lyophilic colloids. Lyophilic colloids. What are lyophilic colloids? Here, the meaning of what? Lyophilic. Lyophilic means what actually? Leo means solvent. Philic means what? Loving. Isn't it? Solvent loving. Solvent attractive type of colloids are what? Lyophilic colloids. That means what happened? In this case, dispersion phase and dispersion medium are having attractive interactions. These two are having attractive interactions. Therefore, these are called lyophilic colloids. Now, in this, if you want to prepare lyophilic colloids, these lyophilic colloids easily we get. Whenever if we mix dispersion medium and dispersion medium, if we mix these two, immediately we get a colloid. Okay. The small work we get what? Lyophilic colloids. So colloid solutions directly they are forming by mixing what happened? Gum, gelatin, starch, rubber, etc. in a suitable dispersion medium, in a suitable solvent. Okay, in a suitable dispersion medium, which is in liquid phase. So we can prepare what these solutions, these colloids easily. So what examples we can take for lyophilic colloids? Gum, gelatin, starch, rubber. These four comes under what? Lyophilic colloids, in which gum, gelatin, starch, rubber are colloidal particles that can be what? Isn't it? Dissolved in a suitable solvent. That is called dispersion medium. These salts are reversible salts. What the meaning of reversible salts means? It means what? When you separate dispersion medium colloidal particles from dispersion phase, okay, you can regain that whatever the colloid by just mixing a suitable what happened medium. You can regenerate that. So we can write like this. So lyophilic colloids, lyophilic colloids, isn't it? They convert into what? Dispersion phase and dispersion medium. Okay. Again, we can bring back that lyophilic colloids here. So that it means what is a reversible source here, right? So what am I going to say here? Dispersion phase and dispersion medium, if we add like this, dispersion phase and dispersion medium, if we add, we are going to get a lyophilic colloids. Lyophilic colloids. Again, we can bring what? Something. Both can be happens. They are reversible action. So these solutions are quite stable. So once we get a lyophilic colloids, what happens? They are very stable. So coagulation is very difficult. So when you see what happened, gum, isn't it? Gum, if you observe what happened. So coagulation, precipitation of gum is what difficult. Once you form what a colloidal solution, so it is very difficult to what getting suspension from that, precipitation from that, because very stable there, because they're attractive. Dispersion phase, dispersion medium attractive actually. Second one, if you observe lyophobic colloids, so this word from lyophobic means again solvent. Phobic means what happened? Hating. So solvent hating. That means the interactions between the dispersion phase and dispersion medium are repulsive. Repulsive interactions are there. Not stable interactions are there. So they comes under what happened? Lyophobic colloids. Colloid soils can be prepared by special method because when you add dispersion phase and dispersion medium, that repulsive forces are operating. So you cannot prepare directly by adding what happened dispersion phase and the dispersion medium. So we need a special methods. So by using that methods, if you mix, then only what happened, we get the lyophobic colloids. Now, whenever some metals like arsenic, like that, metal sulfide, etc., gold, if you take what happened, when you disperse, when you dissolve in the medium, dispersion medium, we get the lyophobic colloids. Right? If the dispersion medium is water, then they are called hydrophobic colloids. If water act as a dispersion medium, you can call that one hydrophobic colloid. These salts are precipitated or coagulated readily with addition of small amount of electrolyte. Isn't it? This is a, for example, gold salt actually. This is a gold salt, right? In which gold is the polar particle and water is the dispersion medium. Now, when you add small amount of electrolyte for this one, small amount of ionic compound electrolyte, if you add what happen, immediately it will give precipitation. That means it is an unstable. So lyophobic colloids are highly unstable because the interactions they are having what? Repulsive interactions. They are irreversible. So once we got gold soul, no, again you can't bring back that. That is very difficult. That means irreversible means what happened? The gold soul, once if you get precipitation in this case, again you can't make from this one gold solution. It's very difficult. So for example, I got a precipitation with addition of electrolyte. Again, you can't bring back the gold solid. What is the difference between the reversible and irreversible salts? First of all, reversible process means it can be regained. You can regain that. It can be reconstituted by simply remixing with dispersion medium. You lost, for example, you lost colloidal solution. You lost the properties of the colloidal solution. Then add a suitable dispersion medium to this one. Immediately we'll get the colloidal solution. That means you can regain that one. But irreversible salts, once we get a precipitation, what happened? Suspension, should we get what happened? Precipitation. Even though if you remix with dispersion medium also, getting that one is very difficult. Regaining is what difficult in irreversible salt. Lyophobic colloids are, what type of colloids they are? Solvent loving colloids. Isn't lyophilic? Lyophilic will be solvent. Lyophilic will be solvent loving. Lyophobic will be solvent hating. It is. So it is lyophobic. So take solvent hating. If it is lyophilic, then it will be solvent loving. The salt which can be reconstituted by simple remixing with the dispersion medium is called, definitely it will be reversible salt. Next, one more classification we'll discuss here based on the size: multi-molecular, macromolecular, and associated colloids. Multi-molecular colloid, macromolecular colloid, and associated colloids. Depend upon the types of the particles of the dispersion phase, colloids are classified into three categories. So first one we are taking multi-molecular colloid. What is multi-molecular colloid? If you see this diagram, okay, now what is the blue color is dispersion medium. The red part is actually what? Dispersion phase. This red part is nothing but dispersion phase actually. And the blue part is nothing but dispersion medium. Maybe it is water. Okay. Now what happening here in this case? These colloidal particles are aggregating. They're associating, aggregating like this. They're aggregating. That means what happened? A large number of particles, maybe atoms, maybe molecules, of a dispersion phase aggregating together to form high size of colloidal range. If you observe this one, here in this one, these are the small particles. Now they are aggregating, being what here? Large massive particles here. So this type of thing comes under what? Multi-molecular colloids here. Example, if you take gold soul. Gold soul, what happens here? To make into colloid, gold soul particles, the gold particles, they aggregate with each other. Together they aggregate and forms a massive gold particles here. So that is the reason that comes under multi-molecular colloids. It contains gold particles of various size, if you observe here, because of what? Actually aggregation here. Some will aggregate less number of molecules, some will aggregate more number of molecules. You can take one more example, sulfur also. Sulfur sol also comes under what? Multimolecular colloids. And this is what happened, S8 molecule. Next one, macromolecular colloids. So if you see what happened, the individual atoms or molecules are in the colloidal range. Now it is colloidal range. Now, naturally occurring macromolecules, if you observe, polymers. Polymers all normally they are having what? High molar mass there. Starch having what? C6H10O5 taken n times. It's a big molecule. One molecule itself is a big molecule actually. So in that case, what happens? Cellulose, higher molecular mass, same molecular mass, higher molecular mass. Proteins, biomolecules, because they are already large in size. So no need to get aggregation there. They're already large in size. So that's such type of what happen, enzymes, such type of particles can form what actually macromolecular colloids. Man-made moleculars are polymers. So polymers you can take polythene, isn't it? The polymer nothing but called macro, because one particle size is what if you observe very lengthy. Even one particle size what happened very lengthy in that. Nylon is also comes under what? Man-made, polystyrene, all polymers. You can take polymers comes under what? Macro. Next, finally, if you observe what happened, associated colloids, micelles, isn't it? Associated colloids. Now, what is this micelles? Let me see this one. Now, when you observe at low concentration, they behave as an electrolyte. They behave as an electrolyte. They dissociate into ions. Electrolyte is nothing but they dissociate into completely they dissociate. At low concentration, they are acting as what? Electrolyte. Substance that ionizes when dissolved in suitable ionizing solvents such as water, example NaCl. Substance which can ionize, completely convert into cation and anion. They are called what? Isn't it? Electrolytes. They should dissociate in water. Where they dissociate? In water. So NaCl is an electrolyte because it will convert into Na plus and Cl minus in the water. Therefore, NaCl is an electrolyte. But at high concentration, isn't it? These exhibit what? Colloidal behavior. At low concentration, they're acting as what? Electrolyte. At high concentration, they're acting as a colloids. So based upon the concentration, at low concentration, electrolytes. At high concentration, acting as what? Colloids. So this is nothing but called micelle formation. So aggregation of the particles thus formed called micelles. So whenever it is happening at high concentration, aggregation of the particles are taking place, and that aggregation, whatever the particles you got, that one called micelles. These are nothing but associated colloidal particles. Now, if you observe surface active agents like soaps, which are the best example for what micelles we can take, soaps and detergents are best examples, isn't it? Now, what are the conditions for formation of what? Micelle? When it will form? When the micelle is forming actually. Let me discuss about this one. Formation of the micelle takes place particularly what temperature? Okay. Above what temperature? The temperature is called what? Kraft temperature. This is very important for one more question. What is TK? Kraft temperature. The temperature above which? The temperature above which micelle is formed, whatever the temperature is called what? Kraft temperature. Similarly, the concentration above which micelle is forming, that concentration can be called critical micelle concentration, CMC. Also can be useful for one more question. Okay, at what concentration a micelle is forming, that concentration you are taking as critical micelle concentration, the above concentration. Okay, for example, after something adding for 1, 2, 3 moles of what the polar particles, isn't it? Then about that amount, you are calling that one as a critical micelle concentration. On dilution, so at less concentration, on dilution, these are acting as electrolytes. Individual ions, they are individual ions, NaCl only there. Once if you increase the concentration, they are acting as actually what? micelle ratio. So best example soaps if you observe. Now generally the soaps critical micelle concentration if you observe 10 to the power of minus 4 to 10 to the power of minus 3 moles if you have this much concentration above this concentration or at this concentration you can get soap particles will convert into micelles. The soap particles will convert into what? Micelles. Okay, at what concentration? Critical micelle concentration. Soap will convert into micelles. So that what is that concentration? 10 to the power of minus 4 to 10 to the power of minus 3 molarity. Molarity because molarity is equal to mole per liter. Soaps have both lyophilic character it will have, lyophobic character also they are having. Now micelles of soaps may be contain as many as 100 or more number of molecules. They may contain 100 or even more also. That means micelle of soap may contain. For example, I want to prepare micelle. How many I need soap particles? 100 or more than 100 also I can need for getting what? Micelle. Let me take some questions here. In macromolecular colloids, what happens here? Individual atoms will be there, but one atom or one molecule is having what actually large size. One, the size of the one is what? Very large. For soaps, the critical micelle concentration best definitely what happened? This one. So this is about the